Okay, this one, it is a bit of a weird one, and a few people asked about it. It's just an ugly triangle. From doing it a couple times, I know a couple ways that help see it. Um, Basically, what we have to do is draw the triangle. The velocity of the boat relative to the water is the 5 on that funny angle. The water relative to the ground is the 2 on that funny angle. To get the velocity of the boat relative to the ground, I just need to add these two other vectors up. So the 5 on its funny angle plus the 2 on its funny angle. Add those two vectors. The sum of those two is the velocity of the boat relative to the ground. So the 5 south 30 degrees west. So from straight south, that's dotted line's my reference line, that's straight south. I want to be 30 degrees west of that and a length of 5. So that's going to kind of look like this. To help make sense of this, I'm going to exaggerate that one. The 5 is the length of it, and the angle fits in here. That big angle is 30. Now where that one ends, I'm going to draw the next vector, and it was 2 meters per second east, 20 degrees south. So for my reference line of straight east, I need to be 20 degrees south of that, and a length of only 2. To exaggerate it, I'm going to make that one a little bit shorter. And the 20 fits in here. The vector sum is going to be the length of the line that connects the very start to the very, very end. So this line. The trick is we need an interior angle, and it's tough to find an interior angle. To get the interior angle, I've been through this one a few times, so I can see why it rattles people at first, but there's a little bit of a visual cue. I'm going to get rid of that green line for a second. If I extend my purple line, my north-south line a little bit farther, and extend my red line a little bit farther, that might help to see. There's a 90 down here. If there's a 30 up top and a 90 down there, then this angle has to be 60. Now if I get rid of some of that, we don't need all this stuff really. We now know that that angle down there is 60. If I reintroduce my green line, that's what I need to solve for. I want the length of that, and eventually I need to know how far the green line is from straight south, so I need this angle. To get that angle though, we're going to have to do some pre-work and get this angle. So we now know two sides and the angle between them. We know the 5, we know the 2. I know that this big angle down here is actually 80. So I can use cosine law to get the side. I can use sine law after that to get this interior angle that I called x. Once I've got x, let's say, I don't know what the number is. Let's say x works out to be exactly 10 degrees. That means that the vector I'm curious about, that one that I drew in green, this one, that means that one is 10 degrees away from the 5, and the 5 was 30 degrees away from straight south. So if the x does work out to be 10, that means that my answer, we'll use cosine law to get the number, is going to be south, the difference between 30 and my angle towards the west. So lots of little things. You need to recognize that there's a 60 down at the bottom of our triangle, which means the interior angle is 80. Then once you get that, you need to find the other interior angle and use it to figure out how far our resulting velocity is from straight south. Hopefully that helps a little bit. I'm going to upload and share it with you. If it doesn't help, just email me back.